Hello guys, I think I'm audible now. Hello guys, I think I'm audible. Okay, let's continue with the question. So for input n, we have to find whether the input received is a perfect number or not. Say for example, here we have input n is equal to 6. So the output which we are receiving is 1. The similar way, for input 10, we are receiving output as 0. It means it is like true or false. If the number is perfect number, we have to return 1, else we have to return 0. So if you put this in logic, so for 6, we have factors 1, 2, 3 and 6 and we have to exclude this 6. So if we summate these 3, if you summate these 3, 3 plus 2 plus 1 is equals to 6, right? So this is a perfect number, so we have to return 1, true, right? So next, if we take n is equal to 10, the second example, so the factors for 10 is 1, 2, 5 and 10, right? So here, if we had all these three factors except 10, so they have given, we have to summate all the factors except excluding the number itself. So we have to exclude the number. So here if we add these three, 5 plus 2 plus 1 gives us 8. So 8 is not equals to 10. So 10 is not a perfect number. So we have to return as 0. So if you want to put this in code logic, how can we? So let us make a solution for this. Solution. Perfect number. So we are taking parameter of type long. So first we have to write the base case, right? So for base case, we know that all perfect numbers are only positive. That means it won't go below 1 or equals to 1. So there is no chance at all. So the base case would be so simple here. If n is less than or equal to 1, then we simply return 0. Okay. Now let us initialize some variable with minimum 1. So below 1 we can't expect. So minimum 1 we can expect. So let us initiate variable sum with minimum 1. So start with 1 because 1 is always a divisor excluding n itself, right? So because of that, we'll start with 1. Now let us have a loop. So now let us have a loop to find all the divisors up to square root of n. So will it solve our problem? So let us understand this in a clear way. First, let us put the logic here. So let us put the loop for so I'm gonna start from 2 because 2 is a positive number. So from here up to square root of n means I into I less than or equals to n. So I plus plus. So from here, so we start from 2 and we traverse till square root of I less than or equal to square root of n. So for example, here we have to write the case. 1 minute, guys. Give me a minute. Yeah, sorry guys. So we traverse till square root of n. So here if n modular division I equals to 0, then what we have to do? We have to add the divisors. So ಇರೋ ಸಮ್ಗೆ I ನ add ಮಾಡ್ತಾ ಇದೀವಿ, right? Upon this, again, if I is not equals to n divided by I. So I'll explain you this later in a clear way. So as of now, try to understand the logic. So here what we are doing, we are adding all the corresponding divisor pairs. So here we are adding all the corresponding pairs which are available to the sum. This solves our problem. So finally we will return either it is true or false. Return sum, if sum is equals to n, return 1, else return 0. Okay, now let us understand this logic by putting some examples. So the given example is n is equal to 6, right? So for n is equal to 6, for n is equal to 6, let us put this in quote. So initially n ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು. So we are doing modulus operation. So if n modulus of I, so we are starting with 2, so 6 mod 2 equals to 0 ಆದರೆ, so obviously it divides, so 6 can be divided by 2, so it is true. So ಇಲ್ಲಿ ಏನಾಗ್ತದೆ, it goes to the loop. So loop ಅಲ್ಲಿ ಏನಾಗ್ತದೆ, sum is equal to sum plus I, sum is equal to sum plus I ಆಗ್ತಿದೆ. ಇವಾಗ sum ಅಲ್ಲಿ ಏನಿದೆ, ಸೊ sum ಅಲ್ಲಿ ಇವಾಗ 1 ಇದೆ. So initially we have initialized sum with 1, so sum is 1 plus I 2. So initially we have 3. Okay, so understand the logic now. Next, if ಇಲ್ಲಿ ನೋಡಿ, if I starts from 2, it should traverse from less than or equal to square root of n. So n is 6, so square root of n is, so next here we have 3, right? Sum is 3. Now, so we started with n is equal to, here I is equal to 2, so I should be traversed until the square root of n. So n, for example, 2 to the 4, next 3 3 is a 9, so it is becoming more, so we can't take that case. So now let us understand this. So 3, next, if it comes to the this if condition, if I, so the now it is 3, if 3 is not equals to 6 by 3, right? Then it goes to this, sum is equal to sum plus n by I. So ಇವಾಗ sum ಅಲ್ಲಿ ಏನಿದೆ, 3 plus 6 by 3 ಇದೆ, so we get 5 here. So again finally, again it is somewhat wrong condition. For here we are checking for 3, so we should not check for 3, should check for 2, because I is 2 here. So let us check condition for 2. So for this condition, 2 is not equal to 6 by 2, right? So then it goes to this, we are adding sum is equal to sum plus n by I. So ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, sum ಅಲ್ಲಿ ಏನಿದೆ ಇವಾಗ 3 ಇದೆ, so as of now it is 3 plus 6 by 2, so we are getting answer as 6. So for end of the statement, so we are getting sum as 6. So ಇಲ್ಲಿ ಏನು ಕಂಡೀಷನು, if sum is equals to n, sum n ಬಂದಿದೆ 6, so ನಮ್ಮ input ಏನಿದೆ n 6 ಇದೆ, so if it is equals to this, then we have to return 1. So that's what we have done here, right? If the input n is equal to 6, the output should be 1. So it justifies our problem. ನೆಕ್ಸ್ಟ್ ಗೈಸ್ ನೋಡಿ, ತುಂಬ ಈಸಿ ಇದೆ. ಕ್ವಶನ್ಸ್ ಇದೇ ಥರ ಬರುತ್ತೆ. ಅಟ್ ಮೋಸ್ಟ್ 90 to 95% ಇದೇ ಥರ ಬರುತ್ತೆ. ಯು ವೋಂಟ್ ಗೆಟ್ ದಟ್ ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಕ್ವಶನ್ಸ್. ಸೊ ಪ್ರಾಕ್ಟೀಸ್ ಡೈಲಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಸೊ ನಾವು ಹೇಳೋ ಕ್ವಶನ್ಸ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ, ನಾವು ಹೇಳೋ ಥರ ಸೇಮ್ ಮಾಡೆಲ್ ಅದೇ ಥರ ಇರೋ ಕ್ವಶನ್ಸ್ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಡೆಫಿನೆಟ್ಲಿ ಯು ವಿಲ್ ಅಚೀವ್ a good score in your Wipro Wilp. So for more clarification, some ಆಫೀಸ್ನ ವಿಸಿಟ್ ಮಾಡಿ. ಸೊ ನಮ್ಮ ಅಪ್ಲಿಕೇಶನ್ ಡೌನ್ಲೋಡ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ವಿ ಹ್ಯಾವ್ ಅನ್ ಅಪ್ಲಿಕೇಶನ್ ಡೀನ್ global.ai ಅಂತ. ಸೊ ಪ್ಲೀಸ್ ಡೌನ್ಲೋಡ್ ದಿಸ್ ಅಪ್ಲಿಕೇಶನ್. ಫಾರ್ ಮೋರ್ ಕ್ಲಾರಿಫಿಕೇಶನ್, ಕಾಂಟ್ಯಾಕ್ಟ್ deanglobal.ai@gmail.com. Okay. Coming back to the question. So let us solve one more question. So which is an easy question again. It is also asked in Wipro Wilp. So a GCD. You have to find the GCD of all the elements in the array. So given input n. So given input n is equal to 3. So the array is 2, 4, 6. Right? So the output which we are getting is the output which we are getting is 2. ಹೆಂಗೆ ಬರ್ತಾ ಇದೆ 2. So GCD is nothing but greatest. It is a greatest common divisor, right? So how to find this GCD? So if you put this into the logic, so we have to take factors of all these three numbers which are available in array. For 2, 4, 6, the factors are the factors would be, for 2 it is 1, 2. For 4 it is 1, 2, 4. For 6 it is 1, 2, 3, 6, right? So in this, identify the intersecting elements. The common elements identify ಮಾಡಬೇಕು. So if you see here, so the common elements are 1, 2. So the multiplication of these two gives us a GCD of these three numbers. So similarly, if the n is equal to 1, obviously the output is 1. There is no logic at all. So next, if you put this into code, the simple logic would be a GCD. How do we find GCD of A, B, C? So the logic which we are studying from past 3 years. So degree logic. So we find GCD of three numbers by GCD of A, GCD of B, C. One way. Next, GCD of again GCD of A, B, C. Another way, GCD of A, C, B, right? Next, what we can do, the next step is we have to initialize array with 0. Why 0? Because it starts from 0th index. So the result would store at array of 0th index. So we are initializing 2. So and loop we have to start from I is equal to 1 to ಎಲ್ಲಿವರೆಗೂ n minus 1 ವರೆಗೂ. ಬಿಕಾಸ್ ಇಲ್ಲಿ 1 ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರು n minus 1 ಹೋಗಿದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇಲ್ಲಿ n is equal to 3 ಅಂತಿದೆ. ಸೊ 3 n is equal to 3 ಕೊಟ್ಟಿದ್ದಾರೆ. ಇಫ್ ಯು ಸಬ್ಟ್ರಾಕ್ಟ್ n minus 1, that is we'll get 2. So we have to start from 1. So ಇಲ್ಲಿ 2 ಕೊಟ್ಟಿದ್ದಾರೆ 2 4 6. So we have to start from 0th index 0 1 2. Still we have till we have to traverse from 0th to 2. So ಈ 3 ಎಲಿಮೆಂಟ್ ಕವರ್ ಆಗುತ್ತೆ. So traverse ಮಾಡಿದ್ದೀವಿ. Next what we have to do, we have to put our result. It is we have to find the GCD. How do you find GCD? GCD of result comma array of I. So this is a simple logic. So if you want exact code, so the exact code would be, so let us complete this function which finds GCD of two numbers. So the input n integers of type array. So now let us initialize result with first element of an array. ಏನದು int result equals to array of 0. Now we have to iterate. Second step is we have to iterate for ಎಲ್ಲಿಂದ 1 ಇಂದ I less than n. So now we have to find the result. So ಇಲ್ಲಿ ಇನ್ನೊಂದು ಫಂಕ್ಷನ್ ಮಾಡೋಣ. So let us create one more function. So to find GCD of two numbers. So what is the logic for that? To find GCD of two numbers. So let us create some helper function. Which takes two parameters. Let us consider int a and b. If a is equals to 0, what we need, we have to return b. So base case else return again. We have to call this function. The base logic is b mod a comma a. So this function would help us to finish our logic. So again we are calling the helper function. So get GCD helper result comma array of I, right? So first initially result ಅಲ್ಲಿ ಏನಿದೆ 0th index ಅಲ್ಲಿ ಅದನ್ನು we have to put here an array of I. Again a base case would be ಏನು ಅಂದ್ರೆ if at any point of time if GCD becomes 1. So at any point of time if GCD becomes 1, we have to end that, right? How do we end that? So let us write one more if condition here. So if the result is equals to 1, then simply return 1, else return result. So whatever the thing that is there in result, that is returned over here. I hope you understand the logic. So in the next class, let us start the topics which were asked in a previous papers other than these easy topics. Let us go to the moderate questions from easy to moderate. So until now we have solved easy questions. So now next let us solve the previous questions itself, but let us go to moderate questions. Okay. So daily practice ಮಾಡಿ at least 3 to 4 questions practice ಮಾಡಿ valid questions so that ನಿಮ್ಮ ಕೋಡಿಂಗ್ ಎಕ್ಸಾಮ್ ತುಂಬ ಈಸಿ ಆಗುತ್ತೆ. ಕೋಡಿಂಗ್ ರೌಂಡಲ್ಲಿ ತುಂಬ ಈಸಿಯಾಗಿ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು. ಆರ್ ಎಲ್ಸ್ ಇಟ್ ಮೇ ಬಿ ಡಿಫಿಕಲ್ಟ್ ವಿತೌಟ್ ಪ್ರಾಕ್ಟೀಸ್. ಡೈರೆಕ್ಟಾಗಿ ಹೋಗಿ ಬರೆಯೋಣ ಅಂತಂದರೆ ಇಟ್ ಈಸ್ ನಾಟ್ ಸಮಥಿಂಗ್ ವಿಚ್ ವಿ write in theory exams. So it is completely logical. You need to have a good practice to solve these coding questions. Even though they are easy, they are somewhat tackling. So for more queries, visit our office, else contact deanglobalai@gmail.com. Our team will reply to you. Thank you.